Let us take a Emery pulse amplitude modulation signals. Modulation signal means how I will construct these waveforms, and what should be the equations, and what should be the signal space diagram representation of this type of modulated signals. What is the band pass representation? What is the Euclidean distance between signal points? What is the Euclidean distance? What is the energy of the each waveform signals? Okay. What is the basis functions? Okay. So in this section we will study these things. So in a digital Emery PAM signal, band pass signal waveform may be expressed as Sm of t is a real part Am g of t e power j 2 pi f c into t, where m, small m, varies from 1 to capital M, and this waveform defined in this interval 0 to Ts. Okay, where the waveform gt is a real valued signal shape of any arbitrary shape, maybe rectangular shape. You can assume this is a waveform g of t like this 0 to Ts. Yeah, any arbitrary shape in between this is 0 to Ts. This can be, these are real signals. Okay, and whose shape influence the spectrum of transmitted signal Sm of t. So the shape of this waveform g of t affect the spectrum of transmitted, determine the spectrum of transmitted signal Sm of t, because A is the different m amplitude. Okay, A1, A2 and A capital M. So because we want impulse amplitude modulation, each waveform differ in their amplitudes. Okay, because A into Am into Gt is a real valued, so Am into Gt into e power j 2 pi fc into t can be written as Am g of t cos 2 pi fc into t plus j Am g of t into sine 2 pi fc into t. If I will take real part of this, Am into g of t into e power j 2 pi fc into t will be equal to Am into g of t cos 2 pi fc into t. So I can write this band pass signal waveform. This is modulated signal where amplitude is varying, like amplitude shift keying. Their amplitude will differ. Okay, and this Am, this set denote the set of m possible amplitude corresponding to m possible k bit blocks of symbols. Okay, equivalent low pass baseband signal waveform can be written as, generally Sm of t is a band pass, so it can be written as Slm of t into e power j 2 pi fc into t. So this is a equivalent low pass representation. So if I'll compare, so I can write equivalent low pass is Am into g of t. Okay, so this is baseband. If this is finite energy signal, I will calculate the spectra. So I will get the baseband spectra. Spectra will look like a baseband signal. Okay. So amplitude Am for symmetrically a Emery PAM can be calculated like this formula. Am equal to 2 into m minus 1 minus capital M into d. 2D is the distance between two adjacent signal amplitudes. Okay, means what is the distance between D1 and D2? This is 2D. A1, A2 between A1 and A2. A1 are adjacent amplitudes. Okay, amplitude of adjacent signals. Okay, so this is analytical expression for band pass signal waveform for Emery PAM signals, and this is for equivalent low pass signal waveform for Emery PAM. Okay, amplitude should be chosen according to this relation. Okay, so now we will find the signal space diagram for this band pass PAM signals using the Gram-Smith orthogonalization procedures. So first I will calculate the energies of Emery band pass signal can be calculated like this. EM is integrate this for calculating energy, integrate this formula. Because Sm of t is a real valued signal, because am into gt cos 2 pi f ct, gt is a real, so it is a real signal, and it is defined over interval 0 to ts. Okay, so it should be sub ts, 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 okay, ts. Okay, in place of t you have to consider this is ts. Okay, so square and absolute value of Sm of t real signal is the square of the real signal. Okay, Sm of t is am square g am square into g square of t into cos square 2 pi f ct. Okay, cos square theta can be 1 plus cos 2 theta by 2 using this. So I will get two separate integrals. This integral result will be 0 because this is g square t, gt is a real signal, cos 4 pi fc into t. If I will plot the waveform, so this is waveform of gt. Okay, so in one interval I will calculate this will be area under this waveform will be 0. This g square t into cos 4 pi fct, this will be gt. You assume this is a in this interval if this is a this type of waveform, so this is a constant. So if you integrate 0 to ts cos 4 pi f c into t dt, this will give the 0. Okay, and this part will be this can be 0 to ts g square of dt. This is energy of the pulse g of t. Okay, so eg represent the energy of pulse. So energy of signal Emery PAM ms signal will be am square divided by 2 into eg. So this tells that this expression tells that so energy of Emery signal depend on amplitude and energy of the pulse. Okay, and you should know that obviously each signal have a different energy because each signal has a different amplitude. Okay, so energy of ms PAM signal is given by this. Okay, obviously this PAM signal is one dimension because Sm of t is am into gt cos 2 pi fc into t. Actually this value is constant value. Okay, this value is scaled with this. So any signal can be written as a linear combination of this. Only this is constant for all waveform Sm of t. m vary, small m vary from 1 to capital M. Okay. So hence, so first you should define what is Grams and orthogonal. You choose first one waveform and normalize the energy of that, normalize that waveform by the square root of energy of that waveform. So we should define a basis function. A unit energy basis signal can be written as f of t, sm of t divided by square energy of that sm of t. After simplification, I will get this. So this is basis function for the this modulation scheme. Okay, पूछता है, write the expression for basis function of this memory PAM. So this is basis function for band pass memory PAM signal. Okay. So since these PAM signal are one dimension, hence they can be represented by general form Sm of t into Sm into Ft, where Sm is, what is the Sm? Projection of the Sm of t on this basis f of t. If you calculate, I will get this m into Eg by 2. Okay. So this is constellation points, because it's one dimension, so it's scalar. So Euclidean distance between any pair of, to know the similarity between signal points, we should calculate the Euclidean distance in place of correlation. So Euclidean distance defined is absolute of difference of Sm minus Sn. These are vectors, because in this case it's one dimension, this is a scalar. So norm of Sm minus Sn, that can be written square root of Sm minus Sn, scalar. So this can be written absolute value of Sm minus Sn, because Sm is Am into square root Eg by 2, Sn is equal to An into Eg by 2. So this can be written, substitute these two expression here in this. Now we know that Am is a 2m minus 1 minus m into d. Am can be written 2n minus 1 d. If you subtract Am minus An, I will get 2m d d m d minus 2n d minus d minus md. If you subtract, I will get 2m minus n into d. So after simplification, I will get this one. This is Euclidean distance. So now we have a Euclidean distance between mth constellation point or nth constellation point. Okay. Hence the distance between, so distance between any pair of adjacent point means S1 and S2 are adjacent point, S2, S3 are adjacent point. So difference between Mn minus M should be 1. So this can be substituted, and then absolute value of this should be 1. So minimum, kabhi kabhi puchta hai, what should be the minimum Euclidean distance between a pair of adjacent memory PAM signal. So you can write this. So for equally probable case, एवरेज एनर्जी कभी पूछते कैलकुलेट करना आपको बताएंगे. फॉर इक्वली प्रोबेबल सिग्नल, एवरेज एनर्जी पर सिंबल फॉर ए बैंड पास पैम सिग्नल इज गिवन एज 1 by m waveforms. So 1 by equal probability case means 1 by m probability into energy of mth. Okay, mth waveform. Mth wave energy is am square by 2 Eg. So if substitute, if you rearrange, so I can write this is, sorry. So Eg by 2m, then am square. Am I know that 2m minus 1 minus m into d. I will substitute here, and then I will take d square here, and then expand this using a minus b equal to a square minus 2ab plus b square. I will expand like this. Again I will use a minus b square here. I will expand like this, and then sum. So I will have this type of summations. Use this relation, summing 1 m times capital M times m, summing small m 1 to capital M. This will give this AP series formulas. Okay. So this can be substitute this value and simplify. I will get this expression of average energy per symbol. For average energy per symbol, I have to multiply equal probability. If are m events, what is the probability in case of equal probability events? Probability of each event will be 1 by capital M. Okay, and then I will take sum this energy of each waveform. Okay, we have calculated mth waveforms, so m vary from 1 to capital M, and this way you can calculate average energy per symbol. Okay, so let us take one example and write the signal space diagram, a constellation diagram for band pass PAM signal. M is equal to 2. In this case, k is 1, means m is 2. So k is log 2, this will be 1 bits. So in mapping, 0 is mapped with the S1 of t waveform, so that can be A1 into GT into cos 2 pi FCT. 1 is S2 of t, A2 into GT into cos 2 pi. Okay. The unit energy basis signal can be written like this. Okay, where easy represent the energy of pulse GT. Hence, they can be represented in this according to the basis vector Sm into Ft, where Sm is the projection of Sm of t on the basis function f of t. That will give this. So now we have S1 and S2 like this. A1 in terms of A1 into square root of Eg by 2, and S2 A2 into square root Eg by 2. Where AM is, this is generalized how to decide the amplitude of the Emery PAM. So M is capital M is 2, so small m varies from 1 to 2. Okay, so this way I will substitute here m equal to 1, so 2 minus 1 minus 2, capital M is 2, so I will get minus d, and if A2 4 minus 1 minus 2 d, this is this. So constellation point can be written in place of A1 A2. I will substitute A1 in place of A1. I will substitute minus d. In place of A2 I will substitute d. So I will get this is. So this is one dimension. So this horizontal axis showing this is basis vector, basis signal, and S1 is a minus d square root g. So this can be d. This point is denoting this point. This point is denoting this point, Eg by 2. Okay. So this is constellation diagram for the Emery binary PAM. M is 2 means it is also called binary modulation scheme. So binary PAM. Similarly, for M is equal to 4, I will use gray mapping, means adjacent point, adjacent constellation waveform. Their bits will differ by 1 bits. Okay, 0 is assigned to S1 of t, then I will assign S2 of t is 0 1. Another to differ S2 and S3 by 1 bits, I will assign this 1 1 as S3 waveform. For mapping S3 waveform, 1 0 between 1 point difference between 1 bit difference between S3 and S4. So I will assign 1 0. So this is this will be A1, A2, A3, A4. Remaining terms in common. Basis vectors, basis signal can be written like this. Okay. So this can be also written in this form. Sm of t is Sm into Ft. Sm is a projection of Sm of t on the basis function f of t. So this way I can calculate this. Similarly, a1 to a4 I can calculate like this, minus 3d minus d plus 3d. Okay. So these are constellation points. So I can represent like this constellation diagram. Es is the average energy per symbol. EB denote the average energy per bit. Suppose this is 0 0, this is a symbol of 2 bits. Symbol of 2 bits. Okay. So the relation between energy of average energy per symbol and average energy per bits will be this. Es equal to Eb into log 2 m log m base 2. Okay. So if you have a Eb, you can calculate Es. Yeah, you can calculate Eb.